Hello and welcome. Welcome to Wonder Wednesdays. This is part of the Great Science Share, and I'm Dr. Chips, and it's absolutely fabulous to be back doing Wonder Wednesdays for the Great Science Share. I did these last year, and as soon as the opportunity came up to do them again this year, I said yes, because to me, Wonder Wednesdays and the Great Science Share is all that is super about science. It's about curiosity, it's about asking questions, and I'm just going to turn my microphone down because I think I might be deafening you. Let's just take it down to there. It's all about finding stuff out, which is at the heart of science. There's a great quote from Einstein that says something along the lines of him not thinking he was particularly clever, he was just passionately curious. And that curiosity is all about questioning things. So, great to be back. And we've got a great first session today with an experiment here. I'm just going to check that all of my camera views, etc. are working. You should be able to see me on a wide shot now, and then we're going to come into a bit of a closer shot. There I am. There's part of the apparatus that I'm going to use for the experiment today. You probably notice I've broken my glasses. Won't go into how I managed that, but hopefully I'll have some new glasses by this time next Wednesday. And also should be able to screen share as well, because I've got some cool things to share with you coming up, such as Medical Mavericks. Here's Tom from Medical Mavericks, which we'll get to in a second. Yes, it all looks like it's working. Super. So each week there is a theme to the Great Science Share. And this week, this theme is all about clean air. Let me just go back to the graphic there. So this Wonder Wednesday is all about clean air. And we're going to be talking and doing experiments all to do with the air around us. And actually how there's an interaction between that air and humans. We need that air, particularly we need the oxygen out of that air in order to live. So I'm going to do an experiment in a bit where I'm going to actually explore my lungs, the capacity of my lungs, how much of that air I can actually breathe in to my lungs, but we'll come to that in a second. Because before we do, I want to show you the Great Science Share website where you can access all of the resources linked to today's session and others as well, such as the videos from Medical Mavericks, which I'm going to show you in a second. So I'm going to jump on screen share. Hopefully you should still be able to hear me. Let's go to screen share here. And then hopefully if I do that and that, there we go. There is the Great Science Share website. So you go to greatscienceshare.org. And on here, to access any of the resources that you need for these sessions that I'm going to be showing you, you go to Find a Resource. And then when you go into Find a Resource, you will see all of the weekly themes coming up by clicking on Weekly Themes. And here we go. So, as I said, first one is clean air. Coming up, we've got themes on space, the outdoors, war on waste, taking action all around sustainability, climate change, really important. We've got the Climate Change Conference coming up in Glasgow in autumn of this year. It's a really important thing that. We've got wonders of water coming up as well. So you click into any one of these to find all of the resources which I'm going to be sharing with you today. Okay, so that's the first thing I needed to let you know. That's where you access them from. I will recap that at the end as well in case I went a little bit too quick. The other thing to say is that this is a two-way thing. We want to give you the resources to do these experiments, and we'd love to see how you got on. So if you're following along on this Wonder Wednesday and you try some of the experiments, please send us some evidence of you doing that, some photographs or pictures of your work, whatever it might be, and you can share that with us in a number of different ways. So let me show you, again jumping back onto the screen share, where you can connect with us and share your science. Can you see on the top there, on that top menu, there's a Share Your Science button. I'm going to click on that. And in here, right, here we go. So, how exciting is this? Professor Brian Cox is supporting the Great Science Share this year. So that event is coming up on the actual site, Great Science Share Day, 15th of June. There's a Q&A with him responding to the questions that you're putting to him about the planet Earth. Awesome, awesome stuff. But just above that, there are three? No, they're not. There are 4 different ways you can share your science with us. The first one is the one we would like you to use, the uploader. You can go, click on upload, and it will take you to an uploading section of our website. And you can share pictures, photos of all the work that you have been doing, okay? You can also connect with us via social media, such as Facebook and Twitter, or you can email us. But there are so many of you engaging in the Great Science Share. We see so much happening on Twitter and Facebook, which is fantastic, but it's sometimes difficult for us to keep up with everything that we see going on out there. So if you really want to make sure that you get your work to us, send it via that uploader, because what I am going to do is I'm going to start each week, the sessions each week, by showcasing some of your great science. So if you want to get your name, work shouted out on the Wonder Wednesdays, of course, make sure that you're not sending in any personal information that you don't want us to share. We've got information about that, what you can and can't send on the website. But if you want to get your work showcased on the Wonder Wednesday, please do send it in via the uploader. And what we've got is we've got some Share It's sheets that we're calling it Share It's. They are, let me show you where you can find those. These are sheets that we have created for you to, now let me just see some shares. Those are other people's shares. Share your science, find a resource, get involved. Oh, I can't remember where the Share It's were now. Weekly themes. No. Oh, no. Right. I will come back to this towards the end. I've printed one out. I've got one here. I can show you it here. These are the Share It's. Let me hold it up to you there. So these are sheets that you can download, and then you can add in your information, and you can snap this, or you can edit. If you turned it into a document, you can edit it. And you can share what you've been doing each week, and you can send us your Share It's. And if you do that via the uploader, just to make things even better, everyone that sends up their Share It's in via the uploader, every so often the organisation Curiosity Box, who make these fab little boxes where you can do engineering-y, sciencey projects from, are going to pick a few out and give away a few free boxes, Curiosity Boxes, to those people. So, double win. We get to see your fantastic science work and engineering work, and you get the potential to come away with a Curiosity Box to explore yourself. So, there we go. Lots of information to share. I need to think to myself where those Share It's are and come back to that at the end. But let's get on to today's experiment. So this week is all about air and about clean air and making links to environment. And air is vitally important to humans. We need to breathe in the air around us because we need the oxygen from that out of that air to help us live. It goes into all the cells in our body and acts as one of the fuels that fuels us. So I was wondering, how much actual air can I get into my lungs? And I found online an experiment that I can do to actually test this. Now, I've set it all up, but I haven't had a go at it yet. So fingers crossed this works okay. Let me explain what we are going to do. And all the different bits of equipment. I'm just going to have a quick slurp of my tea. What we have here is a large jug, okay, plastic container. And let me come to the close cam a second. so that you're a little bit closer. There you are. Okay. What you can see, what I've done on here, now, I'm not sure if you're going to be able to see. Can you see? It's a little bit tricky to see because of the reflection. Let me just try. I really don't want to drop this all on my laptop. That would not be good. Can you see I've marked there? I think you can just see it. There are blue markings all the way down the side of this bottle. Okay, can you see the one at the top there? I've gone the whole way down. What I've done is I have filled, let's just pop this in there because it's going to be going in there in a second. I have filled this bottle with 200 millilitres, which is a measure of volume, of water at a time, and I've marked off on the bottle those 200 millilitres. So I now have this, I'm going to use this bottle as a measuring aid because it now has 200 millilitre graduations the whole way up it. So 200, 400, 600, 800, bit of a practice for my 2 times table there, the whole way up. And what I'm going to do in a second is I'm going to turn it upside down in this big plastic container of water that I found in my garage, actually. And I'm going to then place a piece of piping up underneath and into the water. Now, the aim of the game here is when I turn it over, fingers crossed it works, we're going to try and do it so we get hardly any air into this container, because when I do turn it over, that air is going to rise to the top. And hopefully we won't get any air in it, and the entire thing will be full of water. Because then what I can do is I can take a deep breath in, fill my lungs up, and you can feel your lungs filling up as you breathe in. Okay, you might have learnt in school about how you get air into your lungs with your diaphragm muscle moving downwards and it creates sort of a vacuum in there outside the lungs and draws the air in through the change in pressure. And I'm going to take my breath in, and then I'm going to blow out. I'm going to exhale, is the correct terminology. And when I do that, all of the gas from my lungs is then going to displace the water. So it's going to push the water out into the container underneath. And we're going to be able to see how much water I displace, I push out. And that's going to be equal to the volume of gas that's going to come out from my lungs. And because I've put these graduation marks on it, we can actually measure it. Okay, that's the plan. Should we give it a go? I think we should. Here we go. Right, so let me make sure that you can see okay. So the first step is I'm going to turn this over, trying not to lose any of the water because I filled it right up to the top. Get it underneath, okay, and turn it upwards. Oh, okay, yes. There we go. So can you see I've turned it up, and the water, this is, I mean, you can't really see because obviously water is transparent like the plastic. We've got a bit of refraction going on, but you can see that there is no air in the top. All right, so that's step 1. Okay, step 2 is to get the tube underneath and into the container without dropping the container. I could do with an assistant sometimes for some of these. Okay, right. So it's in. Okay. Now, where's the other end? Oh, here it is. Okay, this water's rather cold as well because I used the hose outside. Right, here we go. So I'm going to breathe in. Okay, straighten myself up. As I breathe out, you should see the gas that's coming out of my lungs, which is going to go up into the container. That'll displace the water out, and we'll be able to measure exactly how much water has come out, and that's going to equal how much gas was in my lungs. So here we go. Just do a normal breath. There we go. Did you see it? Okay, so you can see now that all of the water has now I don't want to pull it right up because if I pull it out, then the rest of the water is going to pour out as well. Let me just try and adjust the camera slightly because I think you can see. Can you see here? Can you see, look, there is just about there. No, there is the edge of the water line that's still left in the bottle. So I'm just going to make a mark to say where it got to. There we go. Now I can pull it out. The rest of the water will come out. But now we have our mark, okay? And I can actually now count up. You can probably see all these markings now a little bit clearer on here. Each one of these, remember, is 200 millilitres in volume. So I can work out my lung capacity because it would be 200, 400, 6, 8, 12, 14, 16, 18, 20, 22, 24, 26, 28, so that's 2,800, and it's about halfway between, so about 2,900 millilitres, so 2.9 litres. Wow, that's actually far more than I thought it was going to be. Someone better double check my maths on that, but I think that's right. 2,000, so each 5 of these is going to be a litre. 2, 4, 6, 8, 10. 1 litre. 2, 4, 6, 8, 10. 2 litres. 2, 4, yeah, 2.9 litres is the capacity of my lungs. What a cool experiment. I did not know that about myself before. Now, talking of cool experiments, the next thing that I want to tell you about today, and I'm going to come back to the wide lens here, is the amazing Medical Mavericks. And I want you to check out this video, okay? Because Tom from Medical Mavericks actually went and had a camera put all the way down into his lungs so that we could see inside his lungs. Now, let me just show you a couple of screenshots from this. You've got to go and watch this. So here is Tom, and he loves to explain all things to do with the human body and the science link to that. And here is a screenshot. I don't want to ruin the whole video for you, so I'm just going to show you a couple of screenshots. Here he is going for, now I've struggled to say this word, a bronchoscopy. Now that's wrong still. I practiced a bronchoscopy. Right, anyway, you look up how to say that word, but it is when you place a camera up your nose and then down your throat all the way into your lungs, and you get to see inside his lungs with pictures like this. How cool is that? That is inside his lungs, and he talks to you actually about the different parts of the lungs, how it breaks off into different pathways, and you get to see inside his lungs. And do you know what they even do? Let me come back to... I'm getting confused. Let's come back here and come back to... They even take a small sample of his lungs by ripping a little bit off. Made me wince a little bit, but well worth watching it. Thank you for a fantastic video. I think we've got more coming from Medical Mavericks over the coming weeks as well. So you'll find that in the resource section under the weekly theme. That's where you need to find it. Okay, so final thing then to tell you about today, and I'm going to very carefully, I really don't want to trip. Wow, that's heavy. Hang on. There we go. Okay, put that down there. Is the activity that we are going to get you to do today. So your resource, you can download it here. The title of this activity for you is Every Breath You Take. And as I said at the beginning, Great Science Share and science itself is all about asking questions. So the question that you're going to be asking as you do this activity is, are the number of breaths we take affected by different types of exercise? Because obviously exercise is important for us to stay healthy. That's it builds up our lung capacity and our fitness levels. And we're going to do a pattern seeking investigation to see if we can spot a pattern between the type of exercise that we do and the number of breaths we take. So what I mean by that is when you start doing some exercise, and again let me just move this out of the way, such as star jumps, okay? You don't have to do them for very long. I certainly don't have to do them for very long before I start to notice a bit of a change in my breathing. Okay? Can you hear it? I'm sure you can on the microphone. You could probably hear me jumping around as well because I've got a microphone on stuck on me. Can you hear my breathing is changing? You start to breathe quicker and you start to breathe deeper, and that's because your body actually needs to get more of that oxygen into your body when you're exerting yourself. Okay, so you're going to do an investigation to see whether or not, if we do different exercises, so that was star jumps, we might run on the spot. Does it change actually how it affects our breathing? So are we breathing quicker for star jumps, or are we breathing quicker perhaps for running on the spot, or maybe doing some press-ups? I won't try and do some press-ups. So how would we go about doing this? Well, this resource talks you through all of the different steps of this investigation. So it's got some videos to watch first of all. Then you're going to discuss, have a bit more of a chat about the changes that you experience in your body when you do exercise. And then we're going to actually set up a bit of an experiment. So I've got my used to be whiteboards here. We could construct a tally chart to record how our breathing changes for different exercises, because we want to do these different exercises and we want to see how they affect our breathing. So we might come up with a number of different exercises. For example, let me choose the two that I just mentioned then. And we might construct a really simple tally chart table. So I can just do this as a T table to start with. Okay. And on this side, we can write exercise. And on the other side, we're going to be recording how our breathing changes. So we want to record how many times perhaps we breathe in a certain time period. So if we did it perhaps in a minute, so we could say breaths in 1 minute. Now with an activity like this, we're never going to be able to make it a perfect fair test by controlling all of the other variables. Because humans are involved and it's very difficult to make it a perfect fair test. But we want to try and keep as many of the other things the same as possible. So for example, we've chosen there to keep the time of 1 minute the same. There's no point in doing half an hour of star jumps and measuring your breathing and comparing that with 10 seconds of running on the spot. That's not really going to help us find any patterns. So we do need to think about keeping the time the same. And then we need a device to measure the time. So I can use my stopwatch on my computer here. And then we could try, for example, doing 1 minute of, first of all, our star jumps. And we could record at the end of that minute how many breaths we're taking in a minute. Now, if you really want to get clever, you don't even have to record them for a minute. You could record them for 15 seconds and then times that number by 4, because 15 seconds is a quarter of a minute. There's 60 seconds in a minute. So you could try recording it that. You could work out the number of breaths per minute that way. So we could try something like star jumps, and then we could try running on the spot. And then we might try another couple of different exercises as well. I'm not going to tell you all the ones to do. I want you to think of them. And then you could gather your data for this and then plot that data in something like a bar graph to see if you can spot a pattern. That is the aim of this activity, to see whether or not you can spot a pattern in the results, the data you find. So, for example, which of those exercises causes you to breathe quicker, and which causes you to not really affect your breathing, and you still breathe at the same rate. So that's your investigation that you are going to do. There are some questions on the sheet for you to further pique your curiosity and get you finding out other things, such as what gas do we breathe in and breathe out? Because I've been very careful today to talk about the air around us and our need for oxygen, but the actual gas that I blew out into that canister might be slightly different. So maybe you can go and find that out as well. And I love this, there's a true false quiz as well as part of your resource to do. So there we go, there's the first Wonder Wednesday. We found out that Dr. Chips has a lung capacity of 2.9 litres, and we've got an activity for you to do. Remember to go to the uploader and share pictures of you doing this. I am going to definitely find out where to find the share its for next week. But you will probably be able to find that out anyway. You have a quick look around the website. You'll be better at finding things than I am. And do watch Medical Maverick's the camera into his lungs. It is a little bit gross, a lot fascinating. So there we go. I will see you at the same time next week for the next Wonder Wednesday. Have a fantastic week of doing your science experiments, and I will see you then. Bye for now.